In this video, we're going to solve the ALEKS problem called Word Problem Involving Calculations from a Normal Distribution. This problem is going to give you some statistical information. It's going to give you the mean of some measurement. Mine is the mean of a distance. And it's also going to give you the standard deviation of that measurement as well, and then ask you a couple questions about the data. So let's begin by just drawing a normally distributed graph of a normal distribution of data. That's a really good looking graph. I'm pretty pleased with myself. So for a normal distribution of data, that center point right there that I just drew, that would be the mean of the data. And the symbol that we typically use for mean is the Greek letter mu. So I'm just going to draw that notation in down here at the bottom, and we'll make a note of that mu is the mean, and for my data, the mean is 19. I don't really care what the units are because it is really not relevant to understanding how to solve this problem. So I have also my data. It says that the standard deviation of my data is 5.3 miles. The symbol that we typically use for standard deviation is the Greek letter sigma. I'm just going to abbreviate that SD for standard deviation. And my standard deviation, I already forgot it, is 5.3 miles. So we know for normally distributed data, 68% of the data falls within one standard deviation above or below the mean. So right here at this point, which is going to be the mean plus one standard deviation, and this point, I'm going to try to make it look a little more symmetrical. This point right here, this would be the mean minus one standard deviation. This range represents normally 68% of the data. So again, 68% of the data points are going to fall in this area, one standard deviation above or below. If we go 2 standard deviations above or below, so this would be the mean plus 2 standard deviations, and then we do the same thing for below, the mean minus 2 standard deviations. That represents 95% of the data. So 95% of the data points are going to fall within 2 standard deviations above or below the mean. And then last but not least, we can go one more standard deviation out, the mean plus 3 standard deviations, and the mean minus 3 standard deviations. And I'm not exactly sure how I'm going to fit this in. Actually, I regret erasing that. I'm just going to move this information. So if we go within 3 standard deviations, I'm just going to make that really big like that. Then that is 99.7% of our data. So almost all of the data falls in the range of 3 standard deviations above or below. Okay, so this is the general information that you're going to need to solve this problem, no matter what questions it's asking you, no matter what type of data it's asking you. So my first question says approximately 68 students have a distance between what and what. 68% represents one standard deviation above and below the mean. So for my data, the mean is 19. And one standard deviation above 19 is 24.3. And one standard deviation below 19 is 13.7. So 68% of the data points in this particular set of data is between 13.7 and 24.3 miles. One standard deviation above, which is that calculation, and one standard deviation below. Now, the next question that it's asking me is, what percentage of students have a commute between 8.4 and 29.6 miles? So to solve this problem, we need to figure out how many standard deviations away from the mean is 8.4. So let's go back to our mean. If we subtract one standard deviation from the mean, we've already done that math, that's 13.7. If we subtract a second standard deviation from our mean, that's going to give us the 8.4. So 8.4 is 2 standard deviations below our mean, and we can really safely assume that this other data point, 29.6, that's got to be 2 standard deviations above. At least I'm pretty sure it's 2 standard deviations above. Let's double check it. So 2 standard deviations above our mean, 19, plus 5.3, that's 1 standard deviation above, and we've already done that calculation, it's 24.3. And then a second standard deviation above, that's going to give us 29.6. Is that what we got? Yes, 29.6. So this range, 8.4 to 29.6, represents 2 standard deviations. That's this area right here, which is 95%, which is going to be 95% of the data points.